So hello everyone, my name is Abdullokh and today we are going to tell you about the robot named Land and Climate Suitability Analyzer for Agriculture. Our goal is to fight against world hunger by using digital technology. Okay, first of all, let me introduce my team members. Khvan Vladimir, who was responsible to make concepts of our robot. Second one is Rustam Zokirov. He researched to use artificial intelligence, machine learning to solve these problems. And as well as our third member is Makhmudova Sevinch. She helped us to test our robot's concept and find any deficiencies and gave optimized solutions for them. Okay, now let's move to the next slide. Here is the agenda for today's presentation. What is the problem or issue? Then we will focus on how we can concept our robot, how our robot will be used to solve this world problem and help society, and potential problems that might happen while you would be using our robot. Hunger is one of the worst violations of human dignity. Hunger divides people, their dreams, and their future. From statistics on the internet, each day 25,000 people, including more than 10,000 children, die from hunger and related causes. It's time to act, and it's time to eliminate hunger from the face of the earth. To solve this problem, we use digital technology, and we trust in artificial intelligence. If we want to feed the world in 2050, in the next 30 years, we need to produce same amount of food as we did over the last 8,000 years. For this, we should secure our food production. But there is a question, how? Now, let's focus on the problem area. In most cases, there are problems in agriculture like plants get various diseases and farmers lose their products and invested money. And there are also areas like people don't know what products and plants can be grown there. And it can lead to lack of food and increase the rate of world hunger. But why this happens? How can we give a solution for that? In such situations, people do not analyze the environment of the land, its temperature, land humidity, and etc. before planting something. Then there can be plant diseases. For example, some plants cannot grow when the sunlight falls directly to the plant, or it can grow only at temperatures like 10 or 20 Celsius and maybe 7 or 8% land humidity. So, by considering these problems, we want to implement a robot that can predict a high probability of plants that can be raised in that area. For achieving these results, our robot will use a dataset of climate of that area, and it will contain a special sensors to calculate other information like temperature, wind rate, humidity rate in the land. After calculating all information, the special screen shows an image and extra information about the plants that can be grown in this area. For example, it can be potato or tomato image. So now let's see how we created the concept for this robot. Now Vladimir will continue our presentation with examples.
Good day. My name is Vladimir Khvan, and I will describe some basic concepts of this robot. Mainly, this robot has one major aim: to diminish poverty by making food more affordable. In order to do it, this robot provides all the necessary information to successfully grow crops everywhere, so that it analyzes the environmental conditions, controls plants' health, and finds a possible treatment for infected crops. Let's start with the first one, analyzing the land, weather, and air condition. Why is it important? In agriculture, the soil is quite an essential aspect. Therefore, the knowledge about Earth's humidity, forms of life under the ground, and the composition of soil decide which crops can be planted there. Moreover, this information is a crucial point at considering the number of gallons of water that should be used and further treatment that should be taken. Next, some attention should be devoted to air composition and weather. Some crops are highly sensitive to weather, such as beets, apples, and many more, and obviously, some plants will die if the air is full of toxins, whereas others can still survive. This robot analyzes surroundings by sending hundreds of laser pulses that let him scan the territory and draw the landscape map. Next, it displays all the data on integrated monitor and gives precise instructions for further action. The second is controlling the plant's growth. During daily bypassing the given territory, it scans crops for all the possible diseases, checks humidity of the soil, and looks for clues of malicious rodents. So that this robot eliminates most cases when crops might be in danger. Therefore, agronomists can breed even better crops in future and moderate crops' DNA according to environmental tendency. Talking about diseases, there is nothing else more profitable than using the experience of dozens of farmers in treatment of crops. Using detailed information that the robot collects from the internet, it compares infected plants to similar ones. Then it looks for qualified, modest, and cheapest way of treatment of plants, making the farming process affordable even for poor regions. Taking into consideration interaction with people, this robot has two cameras on both sides that let him distinguish people, an artificial intelligence system that makes it able to learn surroundings by itself, and a pre-programmed intuitive interface with ton of settings that let the user control the robot. People can easily set the working mode, the timer of bypass, and the time of daily announcements. Moreover, one more feature is a wireless connection that creates a hotspot in a radius of 2 kilometers. Consequently, people from their smartphones can check the location of robot work in progress and its activity at the moment. Also, some technical features of it are highly needed for independent functioning. There are solar batteries and sensors that indicate robot's condition. These sensors are part of standalone system which reports the condition of robot parts. And now Rustam will describe some inside mechanics of the robot.
Hello, my name is Rustam Zokirov, and I'm here to tell you how the artificial intelligence will be used to tackle world hunger and help society. You already know that our main focus area is to improve agricultural productivity with the land suitability analysis and moreover help farmers to grow more and take care of plants when they're growing to minimize the risk of plant diseases. To understand how our robot works, you first need to have an understanding what artificial intelligence is. So, in traditional programming, we define all the rules how the program should work and provide inputs. And at the end, we get a result. On the other hand, in machine learning, we provide data and at the same time, we provide the results, the labels we want to achieve from this data. And machine learning works by combining large amount of data with fast iterative processing and intelligent algorithms, allowing the software to learn automatically from patterns and features of the data. So eventually, in the end, it should able to predict some numbers for the unseen information or data. I hope that you now have an understanding what artificial intelligence is, how machine learning works, and now let's understand what kind of data we can use and how to utilize this data to achieve our goal. Generally, this is the structure that I will follow when talking about the solution space, because it's easier for you to understand what the problem is, what kind of solution we are proposing, and what value it will bring to everyone. First of all, it's about the land suitability analysis, or LSA. The evaluation of land quality plays an important role in the study of land resources. Our X variable called problem is the LSA, and the solution we are proposing is to use the high-resolution images from IRS P6 satellite dataset to analyze the LSA. So then it will able to find the correlation, what happened during some period in a particular area of the land. And at the same time, we can use the multi-criteria evaluation as a matrix and analytical hierarchical process called AHP method, one of the complex one that's commonly used for LSA. And the parameters such as large group of soils, soil depths, or slope, type, height, erosion rate, and other soil parameters will be used to create magic in our algorithm to create some patterns between them. Not only, but we have to take into consideration, for example, the sun rate, for example, the number of sunny days during the months, the number of sunny days in a particular period of time during the year, because some plants need more sun than others. And there are many parameters, all of this feature engineering work needs to be done during the experiment, because we have an idea, we have to code, and we have to experiment, because with just words, with theory, I can't tell you that it will work surely. Try this, because you have to try by yourself. There are many cases, and generally the LSA will bring the value such then we can able to predict what kind of plant we can cultivate in such particular region and get the high productivity. Let's move to the next problem. It's about the plant diseases. I'll explain fast in the example of Tanzania. So in Tanzania there is a cassava, which is very important crop. It provides food for 500 million Africans every day. And when the crops fail, farmers know that they can rely on the cassavas to provide them food. And one of the biggest problems for the cassava is disease. And there are several diseases that make the roots unedible. So the solution, first of all, is to create a data set of leaves with diseases or no diseases. And in the end, we will able to use computer vision tool to create a deep learning neural network model to classify whether the particular plant is ill or not. So there are many. It is just example. We can use in many other plants also. And in the end, I will just add, an electricity revolutionized lives 100 years ago. Artificial intelligence is changing our lives completely today. And it will transform every industry and create huge economic value as electricity did. Thank you.
Hello, I'm Sevinch Makhmudova, and now I'm going to talk you about potential problems of our project, which is land and climate analysis of agriculture. It's not about problem, but about obstacles and limitations of our project. And now let's start. The first one is about cost. We know that cost has a noticeable place in every business for its developing, and agriculture industry is not an exception. As you might know, agriculture is a sphere that has not such a much budget to invest some new innovative practices. Therefore, the cost can be one of the main problems for the upcoming implementation of our project, because the cost may not be affordable for small agricultural businesses. Another problem can be the number of robots. If the territory is large, the higher number of robots is needed, but unfortunately, due to the high cost of robots, it can be difficult for agricultural firms or farmers to buy many robots due to the fact that they are not affordable for them. And the second result of having a plenty robot, that they can sync with each other where they will be in a large area. Another problem is about GPS. We know that in our day-to-day life, almost all devices has GPS because it's very easy to use, accurate and reliable. And our project is not an exception. We had GPS. GPS is needed in our project to supervise the robots accurately. And but we have some problems. We can have some problems with GPS navigation, because GPS signals can be compromised by both natural and human sources, and if it is happen, it can lead to inaccurate data or complete loss of GPS signals. As a result, GPS cannot work properly, and it can affect to analysis results, and they can be misorganized. And one thing that I should mention is that it is not such connected with us, this problem, but it has. Hence, this can be one of the drawbacks of our project. Another problem is about errors during the implementation of our project is monitoring. The people, farmers or other people who will use our product may monitor or control the work of robots through their smartphones. And but one thing that I should mention is that our product can be used in some developing countries, and for example, Africa, and it will be very difficult to provide all users with smartphones in order to get results of analysis and statistics. And that's why our team came up with new idea of having monitors of control functioning of robots. That can result another problem in our project, because monitors can be damaged by natural disasters. We know that our robots will be in a big agriculture areas, placed in open air places, and there they can be damaged by natural disasters such as wind, strong wind blowing, raining, or other natural disasters. There was the problems that our project may face. And thank you for your attention.